We use ciphers to encrypt virtually everything that's transmitted over the internet. It ensures secrecy of information so that only the parties exchanging it will know its contents. Even if the encrypted information is intercepted without the key, it will make no sense to the intruder. And the very design and working principles of ciphers are deeply rooted in mathematics. Hi, I am Neelakantha Bhanu Prakash, the world's fastest human calculator, and I'm going to be deciphering the math behind cryptography. Let's first understand what cryptography is. Cryptography is the art of writing or storing information in a form that can only be understood by a select few people who are privy to it. Traditionally, it was used by spies, military leaders, and diplomats to protect information, but in the digital world, it has limitless applications. Whether it's digital signatures, time-stamping, electronic money transfer, secure network communications, or even the passwords of the accounts you hold, there is cryptography behind it. Cryptography involves creating ciphers, which employ mathematical procedures called algorithms to transform messages into unreadable jumbles. One of the earliest known ciphers is the very famous Caesar cipher, used by Julius Caesar to securely send messages to his army personnel, which only they knew how to read. The Caesar cipher is based on transposition. It involves shifting each letter of the plain text message by a certain number of letters. Historically, Caesar cipher had a shift of 3 letters. If one were to code hello using the Caesar cipher, it would be KHOOR, Khur. But Caesar cipher was a simple one to crack. By shifting the letters by a few positions in either direction, a simple sentence can become readable to casual inspection. Creating ciphers in itself has now become a vocation. Modern-day cryptologists, the experts involved in securing communication across the digital space, from passwords to bank accounts, extensively use ciphers for encryption. Let's use a simple example to understand how ciphers work. Let's suppose the algorithm has the following rule. Every letter in the word will be replaced by another letter equivalent to the value of 3x plus 9, where x is the place value of the letter in the alphabet and the letters are counted in a circular fashion, also known as the modulo rule. Going by this rule, A has a place value of 1, F has a place value of 6. If H with a place value of 8 has to be encoded, we'll first calculate its value using the rule. So for x is equal to 8, 3x plus 9 becomes 33. Since the English vocabulary only has 26 letters, counting in circular fashion here makes sense. In fact, this is called the modulo rule in mathematics. So we get the desired letter, which is 7 places after Z, that is G. If we were to use the same rule to send a message hello, we'd actually be sending GXSSB. And if we look at GXSSB without the rule, it might seem gibberish. But to someone who has the key to decipher it, this seemingly random arrangement of numbers suddenly bears a meaning. This is how encryption works in today's digital world. All the information on the internet is essentially converted into a cipher to securely transmit between computers. While Caesar cipher might seem like a very old-fashioned cipher, almost every single data encryption algorithm of today stems from a similar idea. How do I make sure that I can encrypt a text and make it extremely impossible for someone to decode it? Among many encryption methods there are today, the RSA algorithm is one of the most widely used. The RSA algorithm is based on the logic that when two large prime numbers are multiplied, factoring the product is a tremendously difficult task. Since the density of prime numbers cannot be determined with certainty, the RSA cipher is considered to be one of the most robust encryption techniques. That's why it's universally used anywhere encryption is required. Password exchange, banking, online shopping, messaging, RSA is ubiquitous. Another modern standard for data encryption, the Advanced Encryption Standard or AES, is used to encode everything from classified government documents to the traffic emanating from your very Wi-Fi router. The AES beautifully weaves several key mathematical concepts like linear algebra, matrices, and ring theory to produce a robust mechanism of encryption. But why would cryptographers and mathematicians go to such great lengths to create ciphers using obscure, abstract concepts of mathematics? Well, encryption algorithms offer consistent, scalable, and robust ciphers that are extremely difficult to crack. Not convinced? Let's try to break into the RSA algorithm. Now, the RSA algorithm is based on the logic that when two large prime numbers are multiplied, factoring the product is a tremendously difficult task. And RSA is a public key cryptography that shares two keys. A public key which is accessible to all. Factor it out and you can get your password. And a private key accessible to only the concerned authorities. The public key consists of two inputs. One, the product of two large primes. For example, 992,474,117. Two, a co-prime number of these two prime numbers. Whereas, the private key consists of two prime factors of 992,474,117, which are 23,719 and 41,843. Before sending, the message is encrypted using the public key, and then the recipient uses the private key to decipher it back to the plain text. Without the private key, it's impossible to decrypt the message. However, imagine the case where the public key is 200 digits long. Assuming a modern computer could try 1 million combinations a second, it would take 3.17 multiplied by 10 to the power 86 years, which is 317 followed by 84 zeros, as many number of years to try every single combination. And that would be an impossible feat for any computer to achieve. Similar parallels can be drawn with other encryption algorithms too. That's why they're virtually impossible to crack into. That's the magic of math. Hope you enjoyed watching. This was just a tip of the iceberg of cryptography. Do let us know your thoughts in the comments, and if you like our content, like, share, and subscribe without a miss.